Hi everyone. So in last video we saw how elements are inserted in Hashmap. In this video we are going to look at hashcode equals load factor and resizing and how all of these are linked to each other and Hashmap. We know that a Hashmap is basically key value pairs. Okay. So whenever we try to insert any element into Hashmap, what it does basically it passes this key through a hash code. Okay. And what this hash code does is it returns a integer, okay, in the range of 2 to the power minus 2 to the power 31 to 2 to the power 31 minus 1. So this is the range in which it returns an integer. Now, this integer it does is basically it takes a reminder with length of hash map, or we can say hash map size. Okay. And this gives us index, right? We all know that a hash map is basically an array of list, right? And each of this element is called a bucket, right? So on which bucket this key value pair is going to be stored is determined using this particular formula. Now, so let's say you have decided that okay, this is going to be your bucket, okay? And let's say you have a key value pair, something like roll number and name. So 1S, 2A, 3C. So this is going to be added here, let's say 1S. Okay. It will add 2 here, let's say 2A and 3 here. Okay. Now let's say if there is another, suppose let's say 3D, right? In this case, it may or may not generate the same hash code. We'll look at it later how it generates the hash code using key. But this is a simple case where let's say it tries to go to the same bucket. Okay. Now we know that in hash map the key is always unique, right? So what this is going to do is it will compare this particular key to the key we have here. And let's say this both are equal, right? In this case, it's going to replace this C with this incoming value that is D. So that's where equals come into picture. It equates whether the key is equal to what we already have. But this is a very simple case with integers, right? We can have complex cases as well. So let's say I'll try to demonstrate an example where we have a public class student. Okay. And let's say each student has a roll number. So let's say int roll number, correct? And we have, let's say name, that is string name. And we have, let's say another class that represents the total marks each student got in an exam. Okay. So this would be, let's say int marks. Okay. And we have a map of this. Okay. Let's say as map of a student and total marks. Totally possible, right? Now we know that hash code and equals are both part of object class, right? And they have their own implementation. But what we can do is we can override this. Let's say we override the equals with something like this: public boolean equals. It takes the student s, okay, and what it would return is this dot name equal to s dot name. So it will check if the current name is equal to what name is provided in the input. If this both names are equal, it will consider this as equal. Okay. Now, what would happen if, let's say, there are two students, one and let's say roll number 21 with name Suraj, and again one with name 41 as Suraj. Okay. And let's say these two both generate the same hash code. So this is a student, right? This is student one, and this is student two, right? Remember, this is not a hash map. Hash map is basically your student and total marks. Okay. And let's say this student got marks 100, and this one got, let's say, 95. Okay. Now, since it has the same hash code, meaning it will have the same bucket index. So let's say the index is 2. Okay. So what it will try to do is basically at the index 2, that is here, it tries to insert the first student, that is S1 with 95 marks. Okay. And then again it tries to insert a student S2, right? So what would end up happening is it will determine that, okay, the hash, since hash code is same, we already discussed that hash code, let's assume that hash code is same, so it's going to the same bucket. And now what it will do basically is it will compare this S1 and S2 based on the equals method, right? S1 dot equals S2, right? And since this both, right, is based on equals based on name, what would happen is it will return true, correct? So what would end up happening is this S1, this S2 will replace S1, meaning this would remain, but its value would change to 100. Okay. Now, why this happened? It's because we wrote a equals method, right? That's not that good. Okay. This is not a very good implementation of equals. So generally equals would be like that, that if objects are really equal, it would return equals true. If not, it should return equals false. So hope that makes sense on what equals does. So it basically used to compare the keys. So if the keys matches, it will replace. If the key does not match, it will add the node to the next element. Now, what it means by load factor, okay? So initially, when we create a hash map, it will be of size 16. So there would be around 16 bucket starting from 0, 1 all till 15. Okay. But let's say we have around 5,000 element. Okay. Will this 16 buckets be enough? Because if we look at, right, each element will have around 300 plus nodes. Okay. So something like this. And this is going to be case of each one of them. Now this would make searching very slow. Okay. Searching would be slow in this case. So how we can solve this problem? Because Hashmap was initially made to provide faster searching on key value pairs. Okay, faster searching. Generally, searching is of constant time. Okay, so here what load factors come in picture. Okay, load factor. By default, it's 0.75. So as soon as the 12 buckets of this Hashmap is filled, and we are trying to add an element that is trying to go to the 13th bucket, what it will do is it will resize itself to double the length of what it is currently, that is 0 to 31. And this is what we call resizing. Okay. But when resizing happens, right, what ends up happening is there would be, like different nodes at different indexes, but these 16 buckets need to be resized into 31. So what Java will do is it will calculate the hash code again. Okay. And now it will determine the index based on reminder with 32 and not 16. So this will determine index. And it will again, all these nodes will be reassigned to different buckets based on their indexes. So this is basically what resizing is. Okay. In first lecture, I told you that Hashmap uses three data structure, that is array, list, and the last one is a binary tree, right? So when this binary tree is used, so in Java 8, right, Java introduced this concept of binary tree into Hashmap. So what happens, let's say you have this Hashmap, and on one particular bucket there are too many elements. Okay, so let's say there are too many of them, right? So what would happen is basically, if this size, if the number of nodes is greater than 8, Java automatically converts this into a binary tree. Okay, why? Because searching on this list of linked list, right, will going to take a time complexity of O of n, but on binary tree it would be O of log n, right? So in Hashmap, we want the time complexity for searching to be as fast as it can be. So in case where this Hashmap, which generally does not happen, but let's say in case of the list going beyond 8, in case of this particular bucket, it's going to change it to binary tree. And if again, let's say we remove certain elements and its size becomes less than 6, it changes it back to linked list again. So this is what was introduced in Java 8. Hope that helps, and I'll see you in the next video. Thank you.